Hello students, welcome to Jagannath Mathematics Tutorials. In today's video, we are going to discuss function as a correspondence. Before moving into our topic, if you are new to this channel, kindly like, share and subscribe to this channel. Now let's move on to our today's topic. This is function as a correspondence. In functions lecture 1, we have studied functions as a special kind of relation. You can go to this I button and check for it, right? Consider two non-empty sets A and B. Then a function f from set A to set B is a rule which associates the elements of A to the elements of B such that it satisfies two conditions, right? So the first condition is all the elements of A are associated to the elements of B, right? And the second condition is that an element of A is associated to a unique element in B. Let's see this through an example. We have considered two sets. Suppose this is the set A, which contains 1, 2, 3 and 4, and we have considered another set as B, which consists of A, B, C, D and E. And we have defined a mapping from set A to B. We named this as F1 from A to B. Now we need to check that is F1 a function from A to B, right? For a mapping to be a function, we need to satisfy these two conditions, right? That all the elements of A are associated to the elements in B. Here we can see that all the elements of A like 1, 2, 3 and 4 are associated to the elements of B, right? Means 1 is associated with A, 2 is associated with B, 3 is associated with C and 4 is associated with D and D. So it satisfies the first condition, is satisfied. But now see the second condition. An element of A is associated to a unique element in B. Means see this element in A, 4, this is associated to two elements in set B, which violates the second condition. That is why F1 is not a function from A to B. See, F1 is not a function from A to B because the element 4, which belongs to A, is associated to both C and D elements in B, which violates the second condition, right? So this is not a function. This was our first example. Let's check for the second example. The set is same again, A and B, but this time we have considered a mapping from A to B. We need to check whether this F is a function from A to B. So we have made the arrow diagram. This thing is called the arrow diagram, right? I think you know this. If you do not know this, kindly check out the relations playlist as provided in the I button, right? So this is the arrow diagram. Now you can see that the first condition was what? The first condition was that all the elements of A are associated to the elements of B. But see here, 1 is associated to D, 2 is associated to B and 4 is associated to E. But what about this 3? This 3 is not associated to any element in set B. That's why we observe that f is not a function from set A to set B, since there is an element 3 which is not associated to any element of B. Hence, this violates the first condition itself. So, this is not a function, right? This is our third example. The set is the same set, right? We have defined a function f2 from A to B. Means f2 is from A to B. We have to check whether this f2 is a function or not. We have made the arrow diagram again. This is our set A, this is our set B. See, the first condition was that all the elements of set A are associated to some elements in set B, right? Means 1 is associated to A, 2 is associated to B, 3 is associated to B, and 4 is associated to D, right? Now, see the second condition. See the second condition over here. The second condition was that an element of A is associated to a unique element in B. See, 2 and 3 have the same image here as B, right? This can happen in the case of a function. This can happen, but if you had this case, say this one, any element from set A cannot have two images, right? But these two elements, suppose 2 and 3, they can have the same image over here, right? This is the concept. So, is f2 a function from A to B? We say yes, because each element of set A is associated to a unique element in B, right? Next, we consider this. You have to answer this in the comment section. That is f3 a function from A to B. You need to check those two conditions and you need to answer in the comment box that whether f3 is a function from A to B. You have to type yes or no, right? Next is some notes to follow. Let us quickly see them. A function f from set A to set B associates each element of set A to a unique element of set B. This is basically the definition of the function, right? Terms such as mapping, correspondence are used as synonyms for function. Means we can use the terms like a mapping and a correspondence instead of using the word function, right? We can use them as synonyms. Next is, if f is a function from set A to set B, then we denote it by f such that A to B. We denote it by this symbol. Remember this, right? Next, fourth is, suppose f is a function from A to B and the element A which belongs to A is associated to an element B which belongs to B, as you can see in this arrow diagram. Means A is associated to B. Then B is called the F image of A or the image of A under F, right? Means here this B is called the image of A, image of this element A under the function f. You can also write this b as b equals to f of a. Similarly, if we had say c, right, and we have the image of c as d, then we say that d is the image of c under the function f, and we denote d by d equals to f of c. Similarly, if we had say k and we have the image as L, then you can say that L is the image of k under the function f, and L is a function of k, right? L equals to f of k. I hope this thing is clear to all of you. Then B is called the f image of A, or the image of A under f, and is written as B equals to fa. Next, also this A is called the pre-image of B. Now you see here, suppose this L is the image of K, right? So this K is the pre-image of L. This K is the pre-image of L. Similarly, B is the image of A, right? B is the image of A under the function f. So this A is what? This A is the pre-image of B. This is the pre-image of B under the function f. Similarly, this C is the pre-image of D under the function f. So I think that the concept of image of a function and the pre-image of a function is clear to all of you. Hit a like button if you understood this, and subscribe the channel for more videos. Thank you so much. Now take some examples, right? Here is the first example. Consider f of x equals to 2x minus 3, where x belongs to the set of natural numbers. So all of you know natural numbers. This starts from 1, 2, 3, 4, 5, 6, 7, 8 and so on, right? So x will take from these values, right? Now we have taken f of 1. In case of fx, see here, in case of fx, if we put x equals to 1, we have found out 2 times 1 minus 3, which is 2 minus 3 gives us minus 1. So f1 is minus 1. f2 is 2 into 2 minus 3, which gives us 4 minus 3 is plus 1. Similarly, f3 is plus 3 and f4 is plus 5, right? So we have created this function that f from a to b is a function as every element of the set n is associated to a unique element of R. Now, how can we say this? We can say this with the help of an arrow diagram. This is the arrow diagram over here. You can see here we had taken the element as 1. 1 has the image as minus 1. 2 has the image as 1. 3 has the image as 3, and 4 has the image as 5. So by the definition of a function, we can conclude that every element of the first set has a unique element in the second set. Here the first set was the set of natural numbers and the second set was set of real numbers. So f is a function from the set of natural numbers fn to R as every element of n is associated to a unique element of R. Right? This thing is clear to all of you. Now consider another function fx equals to x square, where x can take any real number. We have constructed this function by taking randomly values of x from the real number. We have taken a -2, -2 a square gives us 4. So f of a -1 is 1, f of 0 is 0, f of 1 is 1, f of 2 is 4. Now by the definition of function, we have each element of this first set, which is the set of a real number, associates to unique element in the second set. Therefore, this is a function from R to R. So is f a function from R to R? Yes, it is a function from R to R, because each element of set R is associated to a unique element of set R. Also, no element has more than one image in R. You can see that, right? Therefore, f is a function from A to B. I hope this is clear to all of you. In the next class, we will discuss domain, codomain, and range of a function. Till then, thank you for watching. Goodbye.